So the reality is that there hasn't been just one policy or one reason for the growth in renewable energy. It's been a lot of different things. It's been individual states passing renewable energy portfolio standards. It's been the federal tax credits. It's been PERPA, right? A law that was enacted in 1978 for other reasons. And it's also been declining renewable energy costs. And all of this has led to significant growth in renewable energy. So that's what we see here. This shows U.S. installed wind and solar capacity since 2000. We can see that wind and solar have really taken off in the United States and are growing at pretty strong rates. So recently, most new generation capacity has been natural gas or renewables. So on the left here, you see um, utility scale capacity additions over basically the last 10 years. Gray are non-renewables and blue are renewables. And so in several years, you can see that renewable energy, wind or solar, has been the dominant source of new generation capacity installed in the United States. And over this time period, increased use of renewable energy has reduced carbon emissions from the electric power sector. But it hasn't been the only source driver of reduced emissions. Remember, we talked about this before. What this figure shows is sort of projected CO2 emissions as of 2005 in the electric power industry. So projected emissions are that dotted line going out to 2017. We had all the expectations in the world that electricity consumption was going to increase, and as a result, carbon dioxide emissions were going to increase. So mostly what happened is that for a variety of reasons, including economic downturn and the financial crisis, as well as increased efficiency and this continuing transition away from manufacturing to a service economy, demand for electricity in the United States did not grow very quickly at all. And so relative to the amount of CO2 emissions we were expecting to put out into the atmosphere, emissions were a lot lower because of lower demand growth. And so that's the pink area. So that shows the reduction in emissions that we might attribute to low demand growth relative to projected emissions in 2005. Now, the coal to natural gas switch, which we've talked about, so utilities retiring coal-fired power plants and replacing them with often combined cycle natural gas units, which are very efficient and emit about half as much CO2 as coal-fired power plants, was responsible for the next really big reduction. And then in green, that shows the reduction in CO2 emissions that would be attributable to non-carbon or renewable energy resources. So things are clearly moving in the right direction. But remember what we're working against. The whole point here is to mitigate the harmful impacts of climate change. And what this figure, I think, should hammer home is that this is a time-sensitive problem, right? If we wait too long to reduce emissions, then we're sort of locked into harmful. We could potentially be locked into harmful climate change scenarios. If we wanted to more or less guarantee that we were going to experience long-term temperature increases by 2100 of less than 1.5 degrees Celsius, we would really need to be on this representative carbon pathway, or RCP 2.6. And so the blue line, and what that shows is that emissions would really need to peak in the next couple of years and then decline to zero and even negative levels by about 2080. In other words, global greenhouse gas emissions need to go to zero, and the electric power industry, they need to go to zero pretty quickly. So even though we've experienced very strong growth in wind and solar power, the reality is we have a long way to go. We've experienced about 10 years of really remarkable growth in wind and solar that has been spurred by government policy, but also by changing economics, better materials, etc. But today, wind and solar only make up about 8% of the installed generation mix in the United States. We still are predominantly a grid that's um, made up of natural gas, coal, and nuclear. And as we look forward and think about barriers to getting to grids that are 100% renewable energy, some of the issues have to do with the fact that new natural gas plants, while they are potentially better than coal in terms of emissions, they are still a pretty significant source of CO2. The other issue is that existing coal-fired power plants, and you could also extend this to natural gas plants, um, could linger for a while. In other words, once we build this infrastructure, it could take some time for them to retire from natural causes, if you will. So one of the things that we've talked about so far in this class, in the lecture about the coal industry, is that for a variety of reasons, and part of this was low electricity prices, part of this is coal plants becoming older and needing to retire anyway, and a big part of it is increased regulations and competition from natural gas power plants. A big chunk of the U.S.'s installed coal-fired power plants retired from about 2010 to present day. About 20%, so 60 gigawatts out of the nation's 300 gigawatts of coal-fired power plants retired in recent years. And this was even with the EPA's Clean Power Plan, which essentially directly targeted coal-fired power plants' emission of CO2, in some doubt. It was never fully enacted. So again, there have been lots of reasons for why these coal-fired power plants retired. But here's the thing. If we go to a company like Duke Energy, who puts out public statements about what types of new generation they're going to build, and what existing power plants they're planning to retire in the coming years, the plan for Duke Energy in 2015 doesn't look a lot different than the plan for Duke Energy in 2029. In other words, even though renewable energy is now cost competitive and cheap, even though we know the dangers of CO2 emissions and the role of those emissions in climate change, even though we have a new, less carbon intensive source of generation in natural gas, Duke Energy is still planning to rely on coal to provide about 20% of its capacity in 2029. So that leaves us with this question, which is, even though 20% of the nation's coal power plants have retired recently, um, why haven't more retired? And really, if we look out into the future, out to about 2030, why does it look like a lot of coal plants are planning to stick around for a while? And this is a key question for this class, and really for anyone who's worried about climate change. So one of the big reasons I would argue is the capital intensive nature of the electric power industry. In other words, it takes lots and lots of money to build power plants, and also the way in which we finance that infrastructure. So utilities don't typically pay cash for that infrastructure. They're almost always borrowing that money. And specifically, let's talk about the use of debt. Remember, so if utilities are borrowing the money to build electric power plants, they're essentially taking out a loan, and they are acquiring a mortgage that they have to pay off over a really long period of time. And paying off that mortgage is a legal obligation. If they don't pay that back, they go bankrupt. So if a company like Duke Energy borrows money, what they're really doing is selling bonds. And as we've talked about, these bonds can be then purchased by investors who are trying to make some money over the long term in order to save for retirement or do something else. And what this arrangement creates for utilities is a regular, constant mortgage payment that gradually pay off the loan with interest. So we've shown this before. This is assuming a capital cost of $500 million. So let's say Duke Energy wants to borrow $500 million. They essentially sell $500 million worth of loan or bonds. So that's sort of the same thing as taking out a loan $500 million, and gradually they have to pay that back, essentially by paying on the order of 32, $33 million per year over 25 years. But one thing that I'd like to point out here is this green dotted line. And in particular, I think it's useful to sort of play a game where you go out different years into the future to see how much money the utility, in this case maybe Duke Energy, would still owe on the power plant. So we can go out to year 15 and then look at how much money they still owe, and it's more than half of the original cost of the power plant, about 270, $265 million still left, even after they have owned and operated the power plant for 15 years, even if it's assumed to be a 25-year project. Even if you go out to year 20, even, you're still looking at Duke Energy owing about $150 million left on the power plant. And so what this means is that even as the cost of solar, wind, and energy storage drops significantly below that of coal or even natural gas plants, utilities may still be resistant to retire power plants early before their capital costs have been recovered. Many power plants are financed, which means that utilities borrow the money and then are obligated to pay that borrowed sum off over really long periods of time. And so the power plants themselves are operated in a way that they sell electricity and make money selling electricity, and then the money they make by selling electricity is used to gradually recover their costs over decades. But this model of financing infrastructure and paying it back over decades and decades means that it's really hard to change quickly, right? It takes a long time for these big assets to recover their costs and be ready to retire, and so therein lies the problem. So if you hear utilities CEOs like Lynn Good at Duke Energy or other utilities, these are all folks that are well aware of the problem, right? That are acknowledge the fact that we need to decarbonize and reduce CO2 emissions from the electric power industry. And the phrase they use to describe the actions that they're already taking to pursue this objective is the ship is turning. So they're basically saying that the challenge of changing course for an electric utility in terms of reducing its reliance on coal-fired power plants or even natural gas power plants is kind of like turning a really, really big ocean liner or a cruise ship. And the problem is that even if you see the iceberg coming from a long way away, and so here the analogy is not an iceberg, but a lack of icebergs, right? So climate change, we still may not be moving fast enough. And part of the reason is because of sort of the financial inertia of capital intensive industries like the electric power industry. They have to retire the assets that they've already built before they build new stuff. And so this is sort of a joke. I saw this online. I think this is really funny. There was no need for Jack to die. So what this means is that unless they're forced to do otherwise via policy action, it might take utilities in the US and other developed countries quite some time to switch over from fossil fuel assets to renewable energy. And this has nothing to do with a lot of the challenges that we've already talked about that come into play when you're talking about incorporating lots and lots of renewable energy into grid. This is just talking about the financial inertia of the utility business. So that's a potentially huge problem, right? If we're talking about leaving coal plants on for, the next 10, 15, maybe longer years. So the question then is, what can we do about this?